All right, everybody, welcome to the first joint Novalug Shropshire Lug meetup. I thank everybody for showing up and for John Alexander in helping organize this from the UK side and helping to get this going, and actually seeded the idea of having this joint and combined. So our presenter today is Chris Ellis. He is the creator and lead developer of Bergamot Monitoring, which he has been working on for about 5 years now. Bergamot is based off of Nagios, and some people like to call it Nagios, and I don't care either way, whatever you want to call it. So I am going to turn this over to Chris now. If people, and I'm jealous of Ian with his beer. It's too early and I'm working, so I can't get one now. But enjoy your beers, grab a drink, turn off your cameras, everyone, please. I will turn yours off if you don't. And thank you, Chris.
Okay, well, thank you very much. So for those who don't know me, I'm Chris. I'm kind of based over in the UK, in London at the moment. I used to kind of be up in Wolves and Shropshire, and hence my association with those kind of groups. So about 5 years ago, I started Bergamot Monitoring, which I tend to call a open distributed monitoring system. So John already alluded to Nagios, and that was kind of the inspiration to an extent, or more importantly, my frustrations of dealing with Nagios on a at the time daily basis was where a lot of what Bergamot tries to do comes from. So it's obviously very different. It doesn't share any code with Nagios, but it does attain and remain a level of compatibility and does offer a migration path. So as a system itself, it does have a huge amount of kind of rich out of the box functionality. So there's a couple of key things. All of the state inside Bergamot is persisted into a database. We also have performance data and metrics out of the box. We also have a much more modern real-time user interface, complete with REST APIs. And we actually have a very low latency of execution of checks from an actual check being executed to being displayed in the UI. And there's some other kind of nice features, are the very fine-grained access controls we've got that certain users need. And the other big difference and thing that makes Bergamot very different from Nagios is that it's distributed by default. So we support both kind of the load balancing of checks across multiple nodes. We also support geographic distribution of checks, whereby we can have checks running from different physical data centers or different sites around the world. Or say you have a large multi-office deployment, you can actually run checks from inside those offices and things like that. And rather than all of these trying to be an afterthought, which is how a lot of the extensions to Nagios ended up, these are all kind of designed in from the beginning, and that gives a number of trade-offs, but does improve the scalability of the platform, so we can scale from one standalone node to many multi-node clusters if we need to. And the other thing that makes Bergamot quite different from Nagios is it is a kind of multi-process distributed system at the end of the day. And through that, we then support the ability to run lots of different types of checks. So Bergamot itself actually has 8 different check engines. We also have 4 different notification engines, and then I'll come on to those in a bit more detail later on. And we can also do some quite interesting things, such as scripted checks using JavaScript, which can enable some really interesting features, such as real user monitoring. Like if you actually want to go and log into a website and do checks like that, you can actually script that and do that in Bergamot. Another very interesting feature that makes it quite unique from a lot of other platforms is it's actually completely multi-tenanted by default. So one cluster can run many completely isolated, what are called sites. So you can actually have multiple monitoring environments that are completely separate from each other but run on the same physical cluster and hardware. And then the other kind of big important thing really was having a migration path in Nagios. Now, it's not a drop-in replacement. You can't just install Bergamot over the top for a number of reasons, but there is a tool to convert configuration from Nagios to Bergamot. And then we have a number of improvements on top of normal Nagios, such as a native and non-blocking efficient NRP support. So you can convert your existing Nagios configuration to Bergamot with a little bit of effort, but not too much of a hassle. And it'll take you days as opposed to weeks, like it would maybe moving to other monitoring systems. So I think we already alluded to a little bit of the history, but I kind of first started this project back in 2014, 2015 time. And that originally came out as a stupid idea I had in a coffee shop when I was writing a config parser for Nagios. So this kind of project started really as writing a configuration parser. And then the idea came into my head, well, if I can read the configuration, it's not exactly very difficult to execute a check. And from that very small kernel of an idea, 5 years of my life disappeared effectively. And so in those kind of intervening 3 years or so, I did actually release 3 versions. And there are people on this talk listening today who have seen my previous talks and potentially played with it in the past. And I did have a couple of people running Bergamot 3 in a few sites. And then for various reasons in kind of 2018, I got a bit disillusioned and ended up taking a bit of a break from the project. And about 6 months, a year ago now, I started working on it again. And it's kind of interesting when you take a break from something, you don't really realize all of the decisions you made maybe 2 years ago weren't necessarily the most sensible, or thinking with things with a new eyes and new mind is kind of quite useful at times. So this talk is pretty much entirely about Bergamot 4.0, which is going to be upcoming release. I'm hoping it's in beta at the moment. I'm hoping to have it out as a release in the next couple of weeks. And the whole goal, to be honest, of this it's been in large extent fairly radical rewritings of certain parts of the core system. And a lot of that has been driven by actually trying to simplify things. So trying to simplify deployment. So before you used to have to deploy something like 10 different services, microservices. These days it's 3 or 4. And improving a lot on the reliability and resilience. So the older versions of Bergamot relied very heavily on RabbitMQ, which ended up being an extremely problematic decision. So a lot of effort has gone into reworking the core communications that go on and actually making it a lot more stable and solid than it ever used to be in the past. And as a nice little bit of trivia, should somebody know it, and maybe this, John, is the question to what will get you a free t-shirt, is why is it called Bergamot Monitoring? And that's because I like Earl Grey tea. So rather than this being a rather dull, boring talk, it would be nice if anybody's got any questions, feel free to ask them. If you don't want to be on the call, just put them in the chat. And the other thing I kind of want to do is mainly actually show you and tour you around my demo system and explain things. So there is, if you go on, so the website bergamotmonitoring.org does actually have a link to demo, and you can actually log in as a limited restricted user if you so wish to. And the first thing I kind of want to, so this is the main dashboard of Bergamot, which is all about trying to focus attention on what's not working. So this being kind of quite a more modern user interface, it actually uses WebSockets in the background to actually update itself in real time. So when we get check results come in, the display will automatically update, and as we can see going on here, hopefully you can see it over the call, is the icons pulse a couple of times and potentially change color and update some other information. So color is the first visual indicator as to whether things are good or bad using the good old-fashioned traffic lights. And if things should be really wrong and you've got some alerts at the moment, these will be displayed at the top of the main dashboard. So the idea is, and those will actually in real time be put onto the dashboard and removed off the dashboard as stuff happens. So the whole kind of main dashboard is there to try and focus your attention to what is kind of the current state of play and what might be going wrong. So a lot of people in the past have, especially when dealing with management types, have been talking about having the single pane of glass onto your infrastructure. And certain organizations really love that kind of ability to get an overview of their system state very quickly. So the dashboard mainly displays two classifications of checks. We have groups and locations. Groups are just completely arbitrary groupings of checks. So for example, we have websites, which can also contain other groups. And in here we have, say, public websites, which then contains a bunch of websites that Bergamot's checking. So we can see at the moment, these are all currently okay. And this kind of state of all of these checks in groups gets aggregated up. So at the top level, we get to see how many checks inside the websites group are currently okay or not okay. Might be having an alert that's acknowledged, etc., etc. And then locations are kind of similar to groups, but they're all about trying to model the geographic location of what you're checking. So they are more there to design around like modeling physical locations that servers might be deployed. So for example, in this particular demo, we have our main data center where this cluster is running and a whole bunch of other stuff. And then we have my office here where I'm sat, although it's technically my flat, which also has a number of checks deployed. And all of these checks are then running local to this location. And by trying to structure information like this, I kind of want to make it very quick to be able to drill down and find the current state of play. And the UI will automatically try to do things like put the worst case first. So any group or check that is currently not okay would be displayed first to try and make things easy to navigate and to try and focus your attention. So the next kind of thing I want to really talk about is going on from the dashboard and stuff, and the main kind of visibility on information is checks. So again, obviously you don't want to restate the obvious to a lot of people, but checks are just assertions about your infrastructure. And checks have a state. They are okay or they're not okay in the simplest form. And then that kind of then is broken down into more granularity as a status. So obviously Nagios basically has okay, warning, and critical, which obviously to be able to maintain a level of compatibility with Nagios we still have, as well as it making quite a lot of sense. We'd also have additional states that are used for certain things, such as we can actually have just purely informational checks that don't alert but just tell you things. Then again, very much like how Nagios works with things, checks and state has the concept of being in a kind of steady state or a changing state. So a check that's in a steady condition, that can be either a good steady state or a bad steady state. And it will be just running normally and checking things normally. Now, should one check fail, it will then go into changing. So at this point, at this time, your check is transitioning between potentially a okay state and a not okay state. And again, it's all configurable, but a check will need n amount of attempts to be either a not okay state or an okay state. So for example, in my demo environment, you need 4 bad checks to be in a steady bad state, at which point a alert would be raised. And checks obviously also have human readable output. And again, this is very similar to Nagios and pretty much every other monitoring system on the planet. Now, one thing that makes Bergamot a bit different to other platforms is we do try to apply a reasonably strict model onto the checks. So checks are broken down into what are called real checks and virtual checks. And I'll go on to some of the detail about those in a bit. And then real checks can be active or passive. And then we, at the low level, and what we mainly see and talk about in the user interface is hosts, services, and then traps, clusters, and resources. So anybody who's used Nagios before, hosts and services will be extremely well known to you. And obviously, a host contains many services. In Bergamot, hosts also contain many traps. And I'll go on to the differences between a trap and a service in a bit. So the key thing with active checks is they are scheduled. So this is the monitoring platform directly going and issuing an execution of that check then being run, and then the result being processed. And active checks rely on check engines to go and execute a particular type of check. So we actually have so as I said before, we have 8 different check engines. So we can run good old-fashioned Nagios plugins. So if you have a pure Nagios kind of estate, and you convert your config over from Nagios to Bergamot will just run it and run your old Nagios checks without any changes. We also then have a dedicated NRPE check engine that allows you to go and execute NRPE commands on remote hosts, but without the overhead of the check and NRPE plugin. We then actually have our own dedicated version of NRPE, which has some advantages if people want to use it, but there's no need to have to use it. We can then also have the ability to directly make HTTP connections and run tests on HTTP calls. Same with SSH, and we can even do Nagios checks over SSH. And we can also go and query databases using JDBC, which is Java database layer. We can also go and query Java applications via the JMX protocol. And we also have a full SNMP implementation. So you can go and fetch data via SNMP, and connect to SNMP agents and get data out. You can also sort of receive SNMP traps, although a lot of that is probably still work in progress in places. And a lot of the kind of what I would term native check engines, so basically everything that's not Nagios, support scripting. So you can actually control how the checks execute using JavaScript.
Hey, Chris.
Yes.
When you said HTTP, can it do like HTTPS with like certificates and stuff?
Yep. So in fact, I should show you. So I've got websites here. So this is actually checking, say, whether my website's up. And this is then doing a HTTPS call. And then we even have specific checks to go and fetch certificate statuses. So it can monitor that your certificates are all up to date and things like that. And actually, it actually can get quite a lot of information about the TLS out there if you want. So if you want to write checks based on that you don't have insecure TLS versions running or insecure kind of TLS encryption algorithms, you can actually get all that information. So kind of the probably main element of checks in Bergamot are hosts. And we can go and have a look at some dummy hosts that I have in this demo. So a host contains services. And so the UI provides us the kind of state of the host itself as well as all the services. And actually gives us ways to try and organize those services into something that's a bit more presentable as well. So if we, for example, have a look at one of my Bergamot systems, we can categorize services and then tag them with applications as well. And then the UI will group them together to try and make things slightly prettier. And as I alluded to, we have performance data out of the box. So all of that stuff is stored into the underlying database and then presented. And then if you want to go and get that data through API calls, you can. We also track some internal kind of statistics about the internals of Bergamot, about how long it's taking checks to execute. So this particular host is taking 7 milliseconds to round trip from it being executed to the result being processed. And then we also display some configuration information. So the next kind of same kind of concept of Nagios is the concept of services. So these are checks that are checking things on a host effectively, or things on a device. So this is a very simple service that's checking the CPU usage on this virtual machine. And again, we get all performance data, and nothing's terribly different to kind of the way things work with Nagios. Where things do start to depart with say Nagios is that Bergamot deliberately calls a service that's not actively checked a trap. So a trap in Bergamot is a service that is checked passively. And passive checks are completely unscheduled. The cluster at no point will attempt to run them. All it will do is process a result should it receive one. And results can be sent in through a number of mechanisms. So they can be sent over an API call to the main kind of web cluster, or they can actually come through one of the worker transports. So you could potentially write your own system that will push in passive results. And then we've got various ways to correlate a result for a passive check to the actual check using either the internal identifiers that Bergamot uses, the configured name, or other references that can be configured. But I don't actually have any examples of traps yet in my demo cluster because my SNOP devices that I had working are no longer working. And then one area that we do differentiate relatively differently from Nagios and potentially other monitoring systems is having the concept of virtual checks. So virtual checks, they behave just like a check in that they have state and they can raise alerts. However, they at no point actually get executed as a thing. Instead, they reference a whole bunch of other checks. And they are computed when those reference checks change. So these are designed to model kind of multi-node clusters. So if we have a look at this Bergamot deployment, we have 3 kind of main cluster nodes that are running the user interface and all the processing. We then also aggregate this information as a cluster. So we have the cluster that knows about those 3 underlying hosts, and its state is asserted via a condition of those checks. So this particular check is asserting that we always have a quorum within that cluster. So in this instance, if we have only 2 nodes that are okay, then this check will start raising a warning. When we only have 1 of those dependencies that is okay, it would raise a critical alert. So the idea here is that this is then trying to model kind of the more complex clustered environments that a lot of people have these days, where actually we don't care if an underlying host disappears or fails. What we care about is the state of the whole thing as a whole. So we can then model those kind of relationships. And these all get computed in real time as the underlying checks change. So as an underlying check changes, that will cause a recomputation of these virtual checks, which will then potentially cause an alert if so. And then, so a cluster is the virtual equivalent of a host, and a resource is the virtual equivalent of a service. So we can kind of check both of these levels, and we have an expression language to be able to define these relationships. And these assertions that you can basically do some fairly interesting kind of Boolean algebra on them. on the underlying checks that you want to monitor. And the other nice thing is it will aggregate all of the metrics together for your cluster. So this is then showing us the readings from all those 3 nodes. So the other thing that's important, kind of the next thing really, is alerts. So obviously, should a check fail, then we want to notify people. And the first step in this process is that obviously we have the number of attempted, or the number of failed checks that needs to happen before a check goes into a bad state or a not okay state. So in this instance, after 4 failed checks, a check will transition into a not okay state, and it will raise an alert. Alerts get logged, and the history of alerts is kept at all points, so that we always have kind of an audit trail or history of alerts, and that allows us to do some interesting things. Alerts, just like in Nagios, can be acknowledged. We can put comments onto them as well. We can mark them as false positives as well, which is useful for a few situations. But obviously the main thing we want to do with alerts is notify people. So I alluded to earlier that we actually have multiple notification engines. So Bergamot can raise notifications via email, SMS text messages. It's got integration with Slack, so you can put messages into Slack channels, or you can actually directly message people in Slack. And it also has a way for you to make webhook HTTP calls. So you can actually go and just call a random HTTP server, and it will fire over the data about an alert for you to then do whatever you want with. So because we store all the kind of history of alerts, it allows us to do some interesting things, such as SLA computation. So we can, in the configuration, provide kind of the SLA guarantees that we need. So in this particular example, we have a SLA defined on the whole cluster, and then we have reports, and we can specify different time periods for those kind of guarantees. So we want the cluster as a whole to attain uptime of 98.5%, and then based on the alert data, the SLA reports will go and provide you that information, and then we can configure kind of fixed period SLAs as well as rolling periods. So we can, so example here, we have rolling, weekly, monthly, and yearly reporting, as well as a kind of calendar year. And thankfully, we've not actually had any alerts, so we don't have any downtime at the moment. And the other interesting thing that Bergamot can do these days is it has a public status page. Okay, so Gustavo, SLA reports are on a per check basis at the moment, so you configure them on a check by check basis. So that can be at a host and a service level, or a cluster and a resource level, and a trap level. And then maybe in the future we might add the ability to specify them for an entire group or something like that, or be able to aggregate them up, but not had a need for that yet. So the other interesting thing we have in Bergamot is a public status page that you can enable. So you can put a simple configuration option into groups that will then make them display on this status page. So the status page is publicly available URL. You don't need any authentication for it, and it's designed to not require much resources to display. So it's designed effectively to be able to be viewed on a phone if something's gone very wrong. The idea with this is, and actually where I used it on one customer, was we had third party that was calling our services, and they had problems their end quite a lot of the time. and we used to get lots of calls from them saying it's not working. So we gave them this kind of page directly as a way to show them that actually everything's fine, and you only call us when this shows something red. And we can also optionally display those SLA guarantees on this status page. So our service manager kind of really quite liked being able to each month go and pull out the numbers, and it was a lot easier than me having to go and compute uptimes for our estate just by pointing this page to her, and then she could feed it straight into her management reports if the platform was up for this amount of time this month. So it's quite a cool and interesting feature that's actually useful in a lot of enterprises or a lot of customer situations that a lot of platforms don't have. And obviously another side to alerts is us not wanting alerts. So just like in Nagios, we have the ability to add downtime for a particular check, so that we can schedule a period where a host might be going offline, or for whatever reason we don't want to raise any alerts during that period. We can do that. At the moment, it doesn't support scheduled downtime. Maybe in the future that'll get added, but not had much need for it at the moment. The other very interesting thing, Bergamot has the same kind of concepts of Nagios when it comes to parenting checks. So you can specify dependencies between checks in Bergamot. And that actually uses very similar syntax to how we do the virtual check references. So we can specify arbitrary relations between checks. So a host can depend on another host, or it can depend on a random service of a host, or service X can depend on service Y, or a whole pool of things as well. The interesting thing that Bergamot does by default is every service is automatically depends on its host. So when a host fails, you will only get one alert for that host. You won't get an alert for all of the services on that host as well, because it kind of, by modeling infrastructure a bit more tightly, we can then make those kind of assumptions about how things are working. And so in that kind of situation, when a host has alerted a service that alerts, it will still log an alert. It won't raise notifications for it. And that alert will be what's called encompassed to the main host alert. So we can then go and see all of the alerts that are basically child alerts of the main alert. So having kind of given quite a good overview of the main kind of dashboard and console and the things it can do, I think it makes more sense now to talk about the kind of distributed nature of Bergamot. So I've alluded to this already, but Bergamot is completely distributed by default. So the whole core scheduling, user interface, so that's scheduling, result processing, the user interface and API components, all cluster. So they can be run on one node, or they can scale up to tens of nodes if needed. And all of that scheduling and result processing workload is distributed across that cluster. So for large organizations where you have, say, thousands of checks running, or you have a very high frequency of checks running, you can scale up, and then you can actually also achieve zero downtime upgrades by doing rolling deployments and things like that. And Bergamot is very designed to effectively never need to be restarted, or never have to. So for example, configuration changes don't require a restart and things like that. But obviously for small deployments, you can happily run one node. The other interesting thing is workers are the actual things that go and run checks. They are always kind of run as separate services and distributed. So there's nothing stopping you putting every service on one machine for a small setup. But the idea is that workers can be distributed both geographically and for kind of load balancing purposes. So worker nodes can be installed into other sites, and then connect back to the cluster. or they can say if we can have 3 nodes locally, and then the checks will get load balanced across all of those nodes. And any worker that's remote, you can have 4 workers in another data center, for example, that will also all load balance the load by default. So how some of this works under the hood, one of the big changes in Bergamot 4.0 was removing RabbitMQ and moving to Zookeeper for a service discovery layer. So all components in Bergamot 4 register into Zookeeper, and Zookeeper holds the current state of play as to what services are active. And then we rely very heavily now on Zookeeper's consistency guarantees to ensure that we always have a consistent cluster. So in situations where we have a network partition between different nodes of the cluster, only nodes that remain on with quorum, so for example, in a 3-node cluster, the side where you have 2 nodes can see each other are the sides that remain active. The other sides will shut down. So this is very important at making sure that the cluster always stays healthy effectively. So whenever a worker is started or a notifier, it will register into Zookeeper, and at the point it's registered in Zookeeper, the scheduling components inside the main UI will start sending it work. So the UI takes care of balancing work across the different workers that exist. And the user interface provides some interesting So the user interface also provides information as to the current registered workers and notifiers in the cluster through the administration section, if you're logged in with user with enough permissions. So with one of the big changes in Bergamot 4 with all of the new communication layer, workers and notifiers need to be able to access all of the Zookeeper nodes and all of the UI nodes, which provides an element of complexity for deploying remote workers. So Bergamot 4 also introduces a new component called Bergamot Proxy, which allows workers and notifiers to connect to the proxy to connect into the cluster. So when we deploy remote workers, we actually connect over WebSockets to the proxy to then access the cluster. And then the proxy node merely shuffles information back and forth from the main cluster to workers. It's probably relatively rare that you'll have remote notifiers, but remote workers is obviously a very common and useful deployment technique. And the interesting thing here as well is there's no difference between the binary that you deploy. You just give it different configuration options as to whether it will talk through the proxy or not. And Bergamot, as well as I alluded to earlier, also has its own version of NRPE called Bergamot Agent, and that again connects over WebSockets to the worker nodes. So at that point, nodes hosts that have the agent deployed on, the checks are routed through from the UI straight to that host. And then there's a communication protocol between the worker and the agent to extract information. And actually at no point does the agent directly run checks. It actually more just provides information back to the worker when the worker asks for it. So there's also kind of security boundaries there as to the agent doesn't directly let you run Nagios commands unless you enable it. So to geographically split up workers, they get tagged into what are called worker pools. So this is merely just a name that we assign to a pool of workers for a specific location. So in my particular demo, there is a worker in the office that's tagged with the worker pool office. And then checks inside this that need to be checked through that specify that they need to use the worker pool office. Now, because Bergamot has a kind of stricter check and object model, we can actually inherit some of that information. So the worker pool for services is inherited from the host, and for the host it is inherited from the location that the host is in. So in this instance, if we put a host into the office location, all of the checks for that host will automatically start running from the office worker pool because that is configured at the location level. So a lot of what Bergamot does try to do is reduce having to duplicate configuration. And if there's a point that there are no workers inside a pool, then checks will get automatically failed with unroutable errors. So the cluster knows what workers exist, they know what workers exist in what pool, and if there are no workers available, the scheduler will immediately issue a failed result. So in older versions of Bergamot, we actually relied on RabbitMQ to do a lot of this routing, which had a whole set of other issues, but also made it relatively complex to move all of this logic into Bergamot 4. So next kind of thing I want to talk through is how you configure Bergamot. So this might put some people off, but the configuration syntax in Bergamot is XML. But I spent a fair amount of attention trying to design it to be readable and compact. And the other big thing was I wanted to solve, or at least to improve, how things get configured. And Bergamot relies on a very heavily inheritance-based approach. So we define configuration templates, which are then inherited. So a definition of a check actually can be very simple. So if I go and have a look at the hosts we have, so this is a dummy host which extends a template, which is a dummy static Linux server. So dummy is a internal check engine where checks are sent to executors, to the workers, and the workers basically just generate a random result and then send it back. So it's used for kind of testing and demo purposes to be able to see checks running through the whole cluster from end to end, but not actually checking real infrastructure. So the key thing here is that we can define a host very simply by just saying what template to use. And unlike, say, Nagios templates, Bergamot templates, all services get inherited. So when we go and look through the configuration that's running, we can actually see what's called the resolved configuration. So from that basically 2 lines of XML, we get the complete configuration. And then this kind of extending of templates happens at multiple levels, and you can also have multiple parents. So at a configuration level, we pull through from a common kind of template all of like the notification settings, and then we pull through the actual check command to go and run for a check from various different levels. So the main idea with this kind of approach is to make it easy to add hosts. So as an example of this, I can go and add a new host with a few clicks. So let's create a new random dummy host, and we can give it a name, and then we can go and add this host. So Bergamot here will go and create the configuration change, and then load that host, and we can go and see that. So we now have a new host added with all of those services inherited, and those checks have been scheduled and will start executing. But we can also go and just force them all to run now. Now, configuration changes all get stored and audited. So we can actually go and view the configuration change that created. So to prove it's not doing anything unmagical and this is all configuration you can write, all that little wizard did was create those 2 lines of XML, which was create a new host that extends the template. So the thing we can then do with Bergamot agent is when we deploy the agent on the server, we can tell the agent its template name. And when that agent starts and connects to Bergamot monitoring, it will automatically get registered and created. So it will do an automatic configuration change. And obviously, if we go and change the configuration templates, it will go and compute all of the affected hosts and update all of their configuration. And all of this, again, we don't have to restart the cluster or anything like this for these changes to happen. And we can go and see the full history of configuration changes that I've made on this demo over the last month or so. So we also get an audit trail, and actually through permissions, we can even do simple workflows where people can raise configuration changes, but they can't apply them. So as well as obviously host configurations, service configurations, cluster resource configurations, we also have contacts and teams. So contacts are users of the system. They are people who are going to get notified, and they are people who can log in. And teams are obviously groupings of those people. We have credentials that allow us to store with an extra level of security authentication details that need to be logged into services. So we can store in credentials SSH keys that we might need to go and log in for SSH, or usernames and passwords, or other kind of authentication details. And then credentials can be looked up by checks when a check is executed. We also have time periods that define when certain behaviors and actions happen. So time periods can control when checks execute, when notifications get sent, and actually all of that uses the Nagios time period format. So for anybody who's familiar with writing Nagios time periods, it's pretty much the same syntax. And then the main kind of workhorse of active checks, so hosts and services, are commands. So commands are things that go and get executed by workers. So essentially, a command is very little more than the name of an engine and an executor within that engine, and then a set of name value pair properties that describe the check that needs to be executed. So for a Nagios based check, this is very little more than a command line string to go run. And we can actually, inside the configuration, use an expression language to make things easier to reuse. So rather than having to remember the weird exclamation mark syntax in Nagios, we can just add a parameter called arg1 or arg2, or you can give those nice names if you put some attention to it. And then we can also go and look up global properties. So we have a globally defined Nagios path, which is defined for the entire site. And then we can even get on to more complex commands that actually contains scripts. So as an example of this, we can have a look at a check that goes and calls the HA proxy statistics interface. So we have a check that's using our built-in HTTP engine, and then it has a script defined using JavaScript that will go and connect to the host, issue a GET request with authentication, and then based on the result, it will actually look at that returned data and then issue a kind of make a decision based on this. So this particular check will actually go and fetch the statistics from HA proxy, which will contain the number of current connections into the HA proxy load balancer. And we can then do checks on that actual data. So we can then go and process and parse that CSV data, and then issue a result where we check a particular threshold that's configured. So this is really powerful for allowing us to build check commands, but without having to write Nagios plugins or other kind, or actually an entire, say, daemon or something like that we might have to do in other platforms. And we can just put this basically straight in as configuration, and we can also reuse this command multiple times. So as a brief overview, Bergamot tries to make configuration a lot simpler than in Nagios land, and easier by allowing as much reuse as possible. So having covered, I briefly mentioned that through when we deploy agents, they will use template names to automatically create themselves. And to control the authentication of agents, there is effectively a shared key. So anybody with those details that I'm now displaying that I will have to rotate are able to actually connect to this cluster and register in as an agent to receive checks and be checked. So before, in previous versions of Bergamot, there was a fairly complicated TLS, mutual authentication and signing system that went on. Now that's a lot simpler, and you just fire up a container or a process with a simple property and a host name to go and connect to, and it will connect your monitoring cluster, register itself, and then be monitored. So kind of one of the other really nice things about Bergamot is the very fine-grained level of access controls you can give people. So at the moment, I'm logged in effectively with super user privileges, and I can see lots of information about checks. I can see all the configuration. I can go and edit checks. I can go and apply configuration changes. I can do what I want. However, we also have another user. So if I switch to Chrome, so in this particular instance, I'm logged in as demo operator, and all of you can go and actually log in as this user if you want. The details are on the bergamot-monitoring.org website, and you can have a look and a look around. So you don't have permissions to edit anything or change anything, but you do have, you can go and like run checks and things like that, and see the state of things. But at no point do you get any access to view or manage keys or to see and manage configuration. And the kind of access control permissions can go down to the level of revoking one of about 30 different permissions or granting a permission to an individual check for an individual user if you wanted to. Obviously, that would be extremely impractical to configure and manage manually. So checks are grouped into security domains. And security domains are basically just a grouping of checks that allow us then to apply access controls for contacts to those groups. So this is often actually specified at the team level. So a contact that is in a team will inherit the permissions of that team. So we have a team called operators, and all they're allowed to do is access the UI. They're allowed to view some statistics. They are allowed to read the state of command of checks. They are allowed to suppress, which means to basically disable alerting. And they are able to acknowledge alerts. So the idea here is if you have a group of a team that is effectively just there watching the state of things and potentially manning callouts or doing stuff, but they don't need the ability to change or reconfigure things, they can then just have very limited permissions and they can't do anything that will break things. We can then also do things like allow database administrators to control and manage their own checks, but not to be able to edit and update checks for Linux servers, for example. So we can actually apply very fine-grained control where, in fact, we can allow it so that two people can't edit each other's checks on the same host. And this is kind of very powerful and was a feature that was requested from some users before we could kind of get this deployed, and goes a lot further than Nagios does in its permission management. And the other nice thing is we do actually have full support for two-factor authentication. So you can actually use YubiKey authentication devices as a second factor to authenticate your account in Google Authenticator. So that can be then enabled and enforced at a per site level, as well as having token-based access to the API. So you can there is a CLI that you can log into remotely to the cluster from the command line. Now, the other interesting thing that Bergamot does is, I mentioned before that it's completely multi-tenanted. So this instance actually has two sites defined. We have my main dev site, and then we also have the demo site. So I don't know how well you can see in the screen, but this has a different URL, but it's the exact same cluster and resources. So I'm logged in, and I can actually, you can use the same email address for each site. So they share absolutely nothing, and this doesn't even have anything configured yet. It is completely blank, and any action we do in here, so all the configuration is completely separate, can't impact the other site, and there's no way for the two to kind of share. So this particular site here only has one user, whereas this particular site here should have two users. Bizarre. So this is really powerful for, say, situations where you want your production environment, your test and dev environment completely separated, or potentially you want systems where you can have each kind of product team or product vertical complete control over their own monitoring environment, but they can't go and affect anybody else's. So you could create a site per different team if you wanted, and they can then manage the system as they want, and you only have to run one kind of central server and cluster. And so workers can be deployed either globally for every site, or they can also be deployed individually per site. So by default, you can just use the kind of effectively shared workers that everybody else is using to execute checks, or you can register in a worker specifically for your site that will then only receive your checks. So I've kind of done a pretty good overview of where the majority of the system is at a kind of reasonable level, that without spending 3 hours of everybody's time. And the last kind of thing really that I wanted to briefly cover was migrating. So a lot of Bergamot's design decisions in places come from the fact that I wanted to enable a migration path from Nagios. So this is why we kept a lot of the same kind of model. So why we have hosts, why we have services. There could have been very other distinct ways to do things, but wanted to be able to actually effectively automatically be able to convert Nagios configuration to Bergamot configuration. So there is actually a CLI tool that will allow you give it a directory of Nagios configuration and it will output the equivalent Bergamot configuration. And it tries to be smart where it can. So it will attempt to build host templates for all of the different kind of variants of service that you have defined in your Nagios configuration, and then reuse those templates as much as possible. So the idea being that if you have converted a Nagios configuration to Bergamot, it won't be perfect, it will be valid, and you will want to manually tweak a few things, but it should be simpler than the original Nagios configuration. And then, there are a few things that can't be migrated because of some of the fundamentals and the kind of internals of how Bergamot does things. So one example of this is people who use effectively single shot checks that execute, say, once a day, or checks that have a very short time period to try and have, say, 2 check executions per day. Those won't work very well because Bergamot very deliberately tries to randomize and skew the scheduling of checks. So those do need some kind of manual tweaking and changing. And then the last thing I wanted to kind of talk about before I bore people and open people up to more questions, I wanted to talk about the future and where I kind of want to take things now I've repicked this up. So one of the kind of things that's become fairly obvious is there is a growing division in a lot of like different monitoring systems between the kind of new container world where everything's more about streaming metrics versus the older world where people want to just assert that the SSH service is running on their server. And what I want to try and do is get to a position where actually I can be a good hybrid of those two worlds, where we can do checks based on actively going and checking if something's okay, because that does still make a huge amount of sense. And it's a lot easier to check a website is up if you go and check it's up than trying to derive its current state through metrics. But at the same time, we need to recognize that the world is doing a lot more of those kind of things, where dynamic environments with hosts that don't necessarily exist for very long. And we've already got some very good groundwork and fundamentals in there, but it needs to be brought up to date. And that's kind of probably where the focus for the next few releases is more going to be on. And then there are lots of ideas about trying to improve configuration editing. So I think that's a very good point to call it a day. And thank you everybody for listening. And if anybody has any questions, please feel free to ask, because I will happily answer as many as people have got.
Alrighty, I have gone ahead and unmuted everyone. So if you have a question, although Roger, a couple people haven't unmuted yet, but if anyone has any questions, feel free to throw them out. No?
Yeah, I have a quick question. So I use Nagios every day. I mean, it's for many years already, and something I always say that is something will be an interesting addition will be tags. I mean, the ability to have those for adding comments, or I mean, especially now, most of the cloud services, they are including the ability to use tags, and it's very useful. What do you think about that?
Yeah, I mean, we to a large extent can do kind of quite similar with the group functionality I've got. But yeah, actually, it's quite an interesting thing for me to add to the wish list. I guess depends on what you want to do with them as well. But interesting suggestion.
Yeah, because sometimes, especially when you have like a big group of people that are using the same system, the same Nagios server, some are not very familiar of like I don't know, they got the alert, so what's next? I mean, is if you can have a tag there like this service or host is like something that it was created by this department, or is something that happens all the time. I mean, I'm not pretending to have something like a knowledge base, but some kind of small
yeah, so it's interesting you say that, because that's something I didn't really cover, but I do have the ability to put notes on things, and actually one of the things that, so in a configuration you can specify descriptions, and actually that kind of information does get pushed out on the alert. So if you wanted to actually effectively annotate your configuration with it's some information about that particular host, that particular check, then you can stick it in as a description in the configuration, and then that will automatically get sent out with alerts. You can also, like if I go and have a look at a host, we can also add comments to hosts. So we've got support for kind of adding random comments. And you can kind of see like downtime histories and alert histories as well. So we have some reasonable support for that. And one of the kind of things I did want to try and do with the configuration was be able to attach a lot more kind of useful information and have that available to people. So descriptions get displayed right next to the kind of host at the top, or any check.
Great. I think that will work for what I was thinking. Thank you.
And Chris, we do have a question in the chat. The
Yeah.
Bergamot GitHub repo has no tagged releases apart from 1.0. Would it be possible to push new tags there?
Yeah, so there's a couple of reasons for that. The others, I think versions 2 and 3 have actually got dedicated branches. But basically, I'm at the point now where I don't consider versions 1, 2, and 3 should be deployed. So I have actually actively kind of basically purged those deployable artifacts. So Bergamot 4 should be arriving as a kind of a release candidate tag shortly. And there are snapshot images available on Docker at the moment. So that's kind of the reason for the tags. I mean, also the other slight reason at the moment is the majority of the development I'm doing these days is actually on GitLab. It does synchronize the commits over to GitHub, but I should probably also update the URLs on my website to try and probably rely on GitLab more. Yeah, and GitLab's also really very, very cool. So moving to it, I've got a full CI pipeline for Bergamot now. So as I do a commit, it'll go and build it. And then hopefully next week it'll also deploy it out to my test cluster.
Awesome. Well, Nick, thanks you for the explanation and is a fan of GitLab.
Indeed. Everybody should be.
Yes.
So much better than GitHub, frankly.
Well, it's not owned by Microsoft, so that's a huge bonus. Any other questions, comments, anything else?
Yeah, I'm also open to any feedback. Like, if you think it's a stupid idea, please tell me. Many people have told me that very directly before.
It's good to have a thick skin, isn't it?
Well, I mean, to be honest, that was a bit of a reason for the small hiatus. Was a friend laid into me particularly viciously.
Oh, nice.
To an extent. But yeah, I mean, also, I think I kind of alluded to it earlier, but when you spend so much time working on something and focusing on something, you do kind of lose the bigger picture a little bit at times. So actually, that kind of grounding on that things weren't really very good in places was actually probably what led me to actually taking some fairly fundamental redesigns in the latest release or the upcoming release.
Nice. Okay. Any other questions, comments?
Yeah, I have another, I don't know, like not a question, but maybe a suggestion is something that happens many times also at work is that sometimes people don't make a, they don't make a, pay attention when they are doing the configuration of their new applications, and the logs start to fill the server. But the disk is not full, so you will not receive the message, the alert, because the disk is still maybe 50% full. But my question is, can you add something that detect rate of growth? Like, I think the name of that is predictive failure or something like that. So if something is sure that it's going to be filled in 2 days, normally it always happens in the weekends. That would
Sure,
be really
that's
interesting.
actually quite a good point actually, because I mean that's certainly functionality I did want to kind of look at adding, and it probably won't be the whole machine learning AI thing that other people tried to do. But yeah, I mean that's actually a very good point. Often looking at potentially the rate of change and then predicting that would be quite a good one. And actually for disk space, pretty easy to do. I mean, we've got kind of all that information there. So well, one of the things that I did want to do with, so for example, if we have a quick look at disk space, we do have all the metrics, so we can actually, let's have a look at how much the disk use is changing. So we do have that kind of data there, and one of the things I did want to be moving forward to doing is actually using the metrics data a lot more than currently happening. So the idea being that you can actually look and inspect the metrics and then probably apply some kind of like time series expression to it. So that kind of approach then would allow us to be able to do things such as what is the current rate of change of the disk space and do those kind of decisions quite easily. So that's kind of probably where I would want to look at adding that kind of support and functionality, would be to try and do that generically for metrics as a whole. But yeah, it's a great suggestion. And it's something that kind of lots of ideas, but just need to get some time. Well, I need to get to do it now. Now that I've kind of got the core a lot more stable and happier with, then that's stuff I can start looking at doing over the next couple of months.
Okay, so I am going to go ahead and stop the recording.